Before I forget, I want to go back and address an issue on this. If your value that you're multiplying by is negative, that standard deviation still changes by a positive amount because it's all about distance away, and distance is always positive, average distance. So technically, I should be absolute valuing that b. Now, of course, it doesn't matter when I come over to here because the minute I square it, it's going to be positive anyways. But just to make sure you don't get tricked on something, so if you have random variable x and then all of a sudden you decide to do -2 random variable x, your standard deviation changes by +2, not -2. Okay, and so these last two are you need to know in terms of answering tricky multiple choice questions, even though you'll never have to do the calculation because they're never going to give it to you. But if the variables are dependent, we need their correlation value, and that has another fancy Greek letter called rho, which looks like a P. Because the formula then takes into account their dependence. And so the formula is, I'm still adding them together, their individual variances, and on the sum, I'm going to add in the correlation value times the product of their standard deviations. Versus on the difference, just like up above, I would be still adding their variances, but this time I would subtract 2 times the correlation value times the product of their standard deviations. Again, you will never have to know those formulas in terms of being able to work them out, but you do have to know that if the variables are dependent, or if they don't tell me that they're independent, I cannot assume that they're independent. And so then I would have to say, oh, can't do that problem. You didn't say they were independent, Torres. Therefore, they might be dependent, and I would need the correlation value. And this is the last, but definitely not least, important concept in Chapter 7, and a great multiple choice question. So the reason that we're using x bar out of your calculator, even though we're writing down mu of x, is that x bar gets really close to approximating mu of x. Now we know x bar is the sample mean, while mu is the population mean. Again, just to throw some more vocab at you, remember, this is a statistic because it comes from the sample, versus this is a parameter because it comes from the population. And of course, I'm sure I've told you once before, that's helped me remember, statistics come from samples, while parameters come from the population. How convenient that they made those the same letter. I don't know if somebody was thinking of that or that just happened. But at any rate, x bar will probably not equal mu. But if we don't bias our data, in other words, we used our famous friend, SRS, it should be fairly close if we use enough data. Then we'll get really close to mu. And the other issue is, dependent upon what's going on with your data, if your outcomes are kind of all over the place, in other words, they're sort of whacked and they're really far apart and they're kind of crazy looking. So if I have a lot, oops, not variables. If I have a lot, I can't sometimes write and talk at the same time. I know it's hard to believe. If I have a lot of variation in the outcomes, then I'll need to collect more data in order to get x bar to equal or really close to mu. And that's what we're going to spend a lot of time on second semester, is estimating mu when all we have is sample data. So that's the end of the notes for chapter 7. We will be practicing for the rest of the week until we get to test day.